Morning. Today we're going to discuss the process of cutting a file from the design finished to the actual cut on the table. And this is going to be one of a series of cuts that we're going to walk through. This is going to be one based off of the test file that's available on the computer, pre-built onto the computer that you get when you order a Wright CNC machine. Now we're going to be doing this with a handheld camera because, of course, this is going to involve both the actual computer itself and the table, and it's much harder to do a screen grab and then go over to the table. So we're going to be doing this by hand to give you that personal experience. All right, let's hop straight into it. So once we have our design built, in this case, we're going to take one of our Wright CNC test files. We're going to go over here to SheetCam, double-click to open up SheetCam, and SheetCam opens up. Now, we have this red area that represents the basic size of the sheet that we have here, and the gray area is representing sort of a generic table size. But let me go ahead and we're going to grab something from over here. We're going to do this together, folks. I'm going to grab myself a measuring tape. I'm going to go over to my sheet of material and take a quick measurement here. I know my material is going to be approximately, we're just going to go with an approximate here. It's going to be just about 12 by 12. It's going to be a little under or a little over, but that's fine. Once we have the basic specs on our material, I'm just going to go up here to options, go to job options, and I'm going to say this is going to be 12. Now notice this shape has also changed a little bit, 12 by 12. There we go, 12 inches by 12 inches. Thickness of my material, I don't need to worry about that in this particular type of process. This is just for routers, not for plasmas. And then, of course, rapid clearance. Rapid clearance is the one thing we will worry about. That's the distance vertically that the torch will travel to start its moves between cuts. That is to say, it'll cut at a lower position, and then when it needs to go to the next starting point, it'll lift itself up in order to clear itself from any of the tip-ups, and then that distance is defined by this here, that rapid clearance. So it's going to go up 3/4 of an inch, move to the next cut, come down 3/4 of an inch, and then begin its next cutting process. I'm going to leave that at 0.75. My origin is in the bottom left-hand corner. That means that my cut will start at the bottom left-hand corner, or that's where the design bottom left-hand, the G-code bottom left-hand corner, that 00 is going to be right there. Perfect. Okay. We're just going to go ahead and hit OK. And now I have my material. I'm clicking and moving the material to the middle of the screen because it's sort of a personal preference, actually. All right. So we have our imaginary sheet of material. We have different options on our screen here. Down I have tools. Tools will allow me to determine, what speed I'm going to be cutting at, a couple other settings. Those will all be determined down here. As a matter of fact, let's take a quick look. I'm going to click on my 16 gauge mild steel tool. 45 amp, 16 gauge mild steel. That's right. I'm going to set my plasma cutter to 45 amps. I'm going to be cutting 16 gauge. But in this case, looking at the plate on the table, I chose 1/4 inch. So I'm going to exit out of here. I'm just going to show you what the 1/4 inch tool looks like. Okay, there we go. 1/4 inch mild steel. This is tool number 3. The kerf width is already calculated by Hypertherm. We can make adjustments to it if we want, but that's not really necessary at the beginning. Feed rate, that's how fast it's going to be cutting. So it's going to be cutting at 48 inches a minute. It's going to have a pierce delay, so that's the amount of time the plasma cutter is going to wait in one position in order to pierce all the way through the 1/4 inch material. In this case, that's 0.6 seconds. And then the pierce height, so this is something determined by Hypertherm, will start off at 0.15 inches off the material. It'll go at a rate of 18 inches a minute and come down to the cut height of 0.06, or about a 1/16 of an inch off the material, in order to maintain that cut. Okay, cool. So I just hit OK. I wanted to make sure that we saw what a tool set looks like and what some of the things mean. Again, we're going to have another video that goes in depth on what each of those tools and how to measure and adjust for those tools as you're working with it. But for right now, that's all we're going to do in terms of tools and tool sets. Next up, we have operations. When we bring in a part, we'll be dealing with operations. Operations are just cut paths. Operations are those tool paths necessary to make a cut. I want to make a cut is similar to saying I want to make an operation. An operation is a cut or a cut path. And then we have our list of parts. So whenever we import a new part into the program, we'll see it listed here. But without further ado, let's go ahead and import a part. I'm going to go up to my file. We're going to go to new part. Perfect, new part. It's going to bring up this screen. Let's go up and let's go. We're in G-code files. I'm going to go to my desktop. I'm going to go to my DXF files. And right down here it says files of type. And it has SVG. I know my parts are going to be DXF, so I'm going to click on DXF. Okay, now I have multiple files on this computer. We're going to go to write CNC test number 2. There we go, test number 2. And I'm going to hit open. Now we're in DXF files, write CNC test number 2, and we hit open. Beautiful. Now we get this screen here. It's called drawing options, and we have a couple of different options. I'm going to go with inches because that file was originally built in inches, and we're going to go drawing position down at the bottom left hand corner. Now the reason behind this is this allows us to position in a very vague sense the part on the material. So we can choose, do I want it to start in the top left hand corner, not the origin, mind you, that's different. What we're talking about is drawing position. So we want the piece to start in the bottom left hand corner. And when I hit OK, you'll see, there's our part. We're going to zoom out here. You're going to see that in relation to the sheet, it's at the bottom left-hand corner. Now, a couple of things we're going to note when we're looking at this art file. We have yellow on the inside, red on the outside. SheetCam understands that there are inside shapes and there are outside shapes. And that'll come into play when we start to deal with offsets. But you'll notice here that the inside is yellow and the red is outside. If we notice that there's red on the inside, then there's something wrong with that file. Either the part is on a piece of the vector is on the wrong layer, and we'll talk about layers later. And then we could also say that the outside, like if this outside layer was white, if this was all white, then it would, now you're seeing, hope you're seeing red there. If the outside layer is all white, then you'll notice that that part isn't actually a complete shape. An incomplete shape is just a line, and lines don't have inside and outsides. They're just lines. So we'll get into that further in another video. Let's keep trucking along. We have a part listed here. It looks good. It has yellow on the inside, red on the outside. Everything is the way that we want it to be. If there's red inside of a yellow, that means it's going to drop out because we want the inside, that yellow, to drop out when we're making this cut. So we're going to go to operation here. We're going to click create a new jet cutting operation, or we can go up here and go to operation and click plasma cut. Either way, it'll get you to this screen. Now we want to make sure, first off, our contour method is on the outside offset. That is, like cutting a 2x4, we're putting the blade width on the outside of our cut. And then anything that's inside cut's going to be cut from the inside. So we want to make sure that's the case. Next up, we're going to go to our layers. We always select a layer. Always select a layer. In this case, this layer is called 0. Now, you may see a number of different things listed there. You just always have to make sure you select whatever is there. Otherwise, it won't know what it's cutting. You may have more than one layer present on a part, and we can show you how to adjust for that to bring it all onto one layer. So just keep that in mind. Always select a layer. Next up, we're going to have to go to our tools. We'll click on the drop-down menu here, and we'll select our 1/4" mild steel tools. Perfect. And it's automatically going to update our feed rate here. Our feed rate is the speed at which we're cutting, and that looks great to me. On the newer versions, there's also something called overcut. We're not going to be discussing that here, but I just need you to be aware that that is an option that you'll see on your screen, so don't freak out. That's there on purpose. Okay. Next up, we have loop sharp corners. Again, a feature that we can talk about in a later video, but not something we're going to address currently because we're not going to be working with this as we first get into plasma cutting. We can sort of explore that at a later date. We can discuss these also as well. Again, I'm going over the basics of cutting, and we don't need to discuss those things at the very basic level. We'll expand upon that later. What you will need in order to make a cut, we do like our lead in and lead out. In this case, I'm going to do an arc. And there's one very basic rule when it comes to your lead in and lead out. Your lead in and lead out lengths have to be at least equal to the thickness of the material. So 1/4 inch material has to have a lead in and lead out that is equal to that 1/4 inch at least. The other thing is we've chosen arc, and I will show you what that looks like when we go to the next screen. So we're just going to hit OK. Okay, and here we go. So you'll notice here that it has this little arc and another arc here, and again, 2 similar arcs. When we said outside offset, that means that this line is on the outside of our vector, and this line is on the inside. And to give you a better view of this, we're going to take a look here. We're going to notice that our part is listed here in white. You'll see that the blade, this little green arrow on the outside, represents the outside edge of the cut, and you'll see that it's making an outside cut. On the interior cut here, you'll see that the vector is on the outside and the cut path is on the inside. And the arc puts the pierce here, it cuts in, puts the pierce here, cuts in, makes a full circle, comes out, and then arcs out. This is your arc in and your arc out. This makes sure that the pierce point for your plasma cutter is set to the inside of the dropout and the outside of the major piece that you're trying to cut. So keep that in mind. Once we're here, it's good enough to cut. So we go ahead and go File, Run Post Processor. Okay, write CNC test number 2, and we're just going to call that number 2.5 and hit save. Perfect. Nothing shows up here. Our file name is in white, so we're good to go. And I like it. Okay, we hit OK. There we go. Now we're going to minimize out of the screen, and we're going to go into our Mach 3 loader here. We're going to go into Profile Update 418. We have multiple profiles over time, and you'll see others, but in this case, on this system, we're using the 418. You may have a more current version. I would use that one, unless otherwise stated to you by tech support, aka me, or, hopefully someone else as well. There we go. We hit OK, and we open up Mach 3. Okay, and we're waiting for Mach 3. Beautiful. There we go. And we see that it says reset in the left-hand corner here. We're going to click on it for it to hit the reset there. Look at that. Now it's solid green. We have this all set up. Now, if I were to try to move with my left down or page up and page down, if I were to try to do anything, it'll change the numbers on the screen, but it doesn't make any changes on the table because the control box is on. Let's take a look at that, and we're going to turn the control box on. And would you look at that there? Okay, now see this big red button here? If I were to hit that red button, it'll actually set an external e-stop. We fix the external e-stop by turning it to the right, and it pops out. And in that way, I can now hit reset, and it allows me to move the table. So we're going to check a couple things. I'm going to hit the up button, and the up button's going to move it away from me. I'm going to go to the down button. Down button's going to move it towards me. Left button is going to move it left. Right's going to move it right. Page up is up, and page down is down. Okay. Now what we're going to want to do, now that we're here, now I'm going to keep my plasma cutter off for this, as we're not going to be cutting this. We're just going to walk through all of the steps necessary to make this cut. And then in another video, in the next video, we'll show you a full cut from design to cut. But this is how we deal with our first dry run cuts, sort of kind of get an idea of what it's going to look like when it's moving. So we'll keep our plasma cutter off to do what we call a dry run. Woo! All right. So we're going to go ahead and, using our left and right up and down keys, we're going to move the torch to the bottom left-hand side of our sheet. Let's take a look here. Nope, not quite bottom left-hand side. I'm going to go ahead and bring it forward, and I'm going to hit my page up and page down buttons. I'm going to hit my page down button here. Okay. And that looks pretty good. Let's take a look here. On this side, it looks like it's on the material. On this side, it looks like it's on the material. Wonderful. I'm just going to raise it up a 1/16 of an inch or so off the material, giving myself a little bit of a gap there. Okay, that's going to be my 0 point. What I'm going to do first, I'm going to go to load G-code, and we're in our desktop Mach 3 G-code files, and we'll go all the way down to write CNC 2, 5, and hit open. Okay, fantastic. Now, you'll notice up here it's saying it's way over here in the top right-hand corner. That's not okay. I'm going to go ahead and zero out my X, Y, and Z. My 0 is on this position. Now, does that mean that if I move my plate over here, I can then move my torch over here, and I can set this as my new 0, but I'd have to do the same process I'm doing here. Once I move it to the bottom left-hand corner of the sheet that I want to use, or, you know what? Maybe I don't want to do it there. Let's go ahead and move it right here, smack dab in the middle of the sheet. Okay, now that I'm there, 0, X, Y, Z. Now, before we hit cycle start, whenever we make a new 0, we have to press one button, and one button that's more important than anything else you could do in this program. One button, Regen Toolpath. You'll notice it pops up properly in the screen, Regen Toolpath. It takes all of the G-code that was written for the previous 0 and ensures that this is now following the new 0 in the system. The new 0 that we just made is now applicable to this G-code. We hit Regen Toolpath, and we're good to go. Okay. We're good to go. Looks like that's there. In an actual cut, we'll make sure our plasma cutter's on, that our air components are also on. So we want to make sure that those are the case. We're not doing that right now because we're doing a dry run. Okay, moving on. There, here, we regen our toolpath. 0, 0, 0. There's no errors going on right here. You'll see it in the status bar. It's not there. Okay, we're going to hit cycle start. And it's going to stop right there. It'll say press cycle start after tool change. This is something built into our profile that allows us to pause. If we do need to double check what tooling we're using, I do double check this. This is 45 amps on 1/4 inch mild steel. If I notice that I'm using 16 gauge mild steel and I see that I have a 1/4 inch mild steel written part, you're going to run into a couple of issues there. So this is your chance to double check that you have the right consumables, the 45 amp consumables, and the mild steel all set at 1/4 inch. Good way to double check. Now that we've checked all of that, look, I got that 1/4 inch there, and I'm actually not running the right consumables. I'll have to change that when I start to turn on my plasma cutter, because these are fine cut consumables here, and those will not cut through a 1/4 inch properly. Okay, I'm gonna have to change that when I do an actual run, but for right now, I don't need to worry about it. 1/4 inch plate sitting here. We're just gonna do a dry run here. We'll hit cycle start. Then it'll go to the first cut, come down, touch the material, lift off the material, and then simulate an actual cut. And right now it's going 48 inches a minute, and it's simulating the circle and the arc out. Perfect. Moving to the outside edge, coming down, and look at that. That's fantastic. Okay, so it's making the cuts in a simulated manner. 4 inches by 4 inches with curved edges. I like it. Okay. Keep going. Good. It's going to come around and arc out and lift up. There we go. And that's the end of the cut. Beautiful. Okay, I want to go ahead and do that again. Let's go ahead and do that again, except I'm going to have you listen to one other thing. So we're going to move our Z-axis around. We're going to move it to a different position, and I'm going to hit page down so that I'm a 1/16 of an inch off the material there. Looks about right to me. We hit 0, X, Y, Z, regen toolpath. Okay, we're good to go. We regened our toolpath, 0, X, Y, Z. This is our new 0. We're going to go ahead and hit cycle start. It's going to stop at the first tool set, 1/4 inch mild steel, 45 amps. If I was running the plasma, that would be important. We're not doing that now. We hit cycle start. Perfect, okay. Oh, I am sorry. There we go. Let's retry this again. And there we go. Coming down, lifting off, and simulating the cut. Now, what you'll notice is if you listen to the control box very closely, you'll hear that every time the plasma comes on, it's going to make a click. Now, you're not going to hear this with the plasma cutter running because, well, the plasma cutter is really loud. But in this dry run, you should hear a click every time the plasma cutter should be on and a click every time the plasma cutter should come off. That signifies that the relay is actually working, and the relay tells the plasma cutter exactly what it should be doing. So that looks like it's going to be a successful cut. I can go ahead and turn on my plasma cutter and give this another cut, and we can do that in another video. There we go.